Okay, so diving in here, getting right into it, we're looking at some really interesting, possibly like game-changing stuff in the world of medicine,
Yeah, for sure.
particularly for folks dealing with type 1 diabetes.
Right.
We've got this article from Beyond Type 1. It's from January 8th of this year, 2025, and it's all about this new technology, HIP, developed by a company called Sana Biotechnology.
Okay, yeah, I've seen this. It's really interesting stuff. So for anyone listening who maybe isn't super familiar, type 1 diabetes, it's an autoimmune disease, right?
Right.
Where your own immune system, it kind of goes haywire and starts attacking the cells in your pancreas that make insulin. Those are called islet cells.
Yeah, and of course, insulin is like completely crucial for keeping your blood sugar levels in check.
Exactly. Absolutely vital.
So, when those insulin-producing cells get really messed up, one of the ways doctors have tried to deal with it is by transplanting new islet cells.
Right. Islet transplantation, that's been around for a while, but it's got its own set of challenges.
Yeah, and the big one, as I understand it, is the body's natural reaction to those new cells, right?
Yeah, that's the huge hurdle. Your body's immune system, it's like a super vigilant guard. Anything it sees as foreign, it tries to kick out.
So it attacks the transplanted cells just like it would a virus or bacteria or something.
Precisely. And to combat that, patients have to take these really powerful anti-rejection drugs, immunosuppressants.
Yeah, and those drugs, while they're obviously necessary in a lot of cases, they come with a whole bunch of potential side effects.
Oh yeah, for sure. It's a real trade-off. Risks of infections, kidney issues, other long-term health problems.
So really what we're trying to understand here in this deep dive is all about this HIP technology that Sana's developed and what this article suggests it could do for type 1 diabetes treatment.
Right, and the really exciting thing is it looks like it might actually get around needing those anti-rejection drugs completely.
Now that would be huge.
Oh yeah, absolutely a game changer.
Okay, so the article says they've actually had success with this, right?
Yes, they have. They've got this person living with type 1 diabetes who's now producing their own insulin again after receiving these HIP-engineered islet cells.
Wow.
And, get this, no anti-rejection drugs at all.
That's incredible. So we know they transplanted modified cells from a deceased donor, right?
Correct.
What did they actually do to these cells using their HIP technology to make this immune evasion happen?
Okay, so the core idea behind HIP is basically, it's like making the transplanted cells invisible to the immune system.
Invisible.
Yeah, like they're wearing this incredible camouflage, The recipient's immune system just doesn't see them as a threat.
Huh. Cellular camouflage. That's a really good way to put it.
Right, it's like they just blend right in.
So the immune cells just kind of cruise right by, don't even notice them.
Exactly.
I see. Now, the article goes through some of the key findings from this first study they did with a human patient.
Uh-huh.
And the first one they talk about is something called, hold on, let me get this right, islet cell function and persistence.
Right, so they're looking at whether the transplanted cells are actually doing their job and, importantly, if they're sticking around.
Yeah, so what did they actually see? Did these transplanted cells actually work?
Well, after 4 weeks, they checked the levels of something called C-peptide in the patient's blood.
C-peptide, what's that?
So basically, whenever your body makes insulin, it also releases a little bit of the C-peptide alongside it. It's like a byproduct.
Okay.
So if you see C-peptide going up, that's a really good sign that those transplanted beta cells, the ones that make insulin, are alive and kicking and actually producing insulin.
Oh, I get it. So it's like a signal that those cells are doing what they're supposed to.
Exactly.
And the article says they did see a rise in C-peptide, which means those transplanted cells were producing insulin.
Yep, and all without any immunosuppressants. That's a big deal, a huge difference from how islet transplantation has been done before.
Right, because before, those anti-rejection drugs were basically mandatory.
Pretty much, yeah. So seeing insulin production without them, that's a significant breakthrough.
So the cells are working, and they seem to be surviving. The article also talks about immune evasion.
Right, the camouflage we were talking about earlier.
So it sounds like it's actually working.
It really does. Remember, the whole point of those HIP modifications is to stop the immune system from recognizing the transplanted cells and rejecting them.
Yep.
And the fact that the immune system didn't attack those cells, that's a big win for the HIP technology.
Pretty amazing. Now, they didn't just rely on blood tests, right? The article mentions some MRI evidence, too.
Yeah, that's right. They used MRI scans to actually look at the transplanted cells 28 days after the transplant.
So what did the MRIs show?
Well, the scans showed that the cells were still there, and even better, they seemed to be functioning well.
So they're not just surviving, they're actually doing their job.
Exactly. That visual confirmation from the MRIs really backs up what they saw with the C-peptide levels.
So we got multiple lines of evidence suggesting that this is working.
It's really encouraging stuff.
And importantly, at least for this initial 4-week period, the article says there were no safety issues reported.
Yeah, that's great news. Obviously, they'll keep a close eye on safety as the study goes on.
Of course, long-term monitoring is crucial.
Absolutely. You always want to be cautious, especially in these early stages.
Okay, so taking all of this together, what could this actually mean for people who have type 1 diabetes?
Well, think about it. Not needing those anti-rejection drugs anymore.
Just that alone would be a huge quality of life improvement.
Oh, absolutely. It'd be life-changing for a lot of people. No more constant worry about infections, kidney problems, all those other risks.
Right, those side effects can be really serious.
It can be very serious.
And this HIP technology, if it pans out, could mean getting those islet transplants without that whole burden of immunosuppression.
And on top of that, they'd be producing their own insulin again, naturally.
This is pretty mind-blowing. The article actually even uses the word cure.
Yeah, they say these results bring us closer to a potential cure for type 1 diabetes.
Of course, it's early days. Just one patient so far.
Right, it's just the beginning, but it's a very promising start.
But still, to even be talking about a potential cure for type 1 diabetes, that's pretty remarkable.
It really is. I mean, we've been managing this disease with insulin injections for so long.
Right, it's been all about managing the symptoms, keeping things under control.
Exactly. But now, with this HIP technology, it's like we're actually addressing the root cause, the missing islet cells.
Yeah, and doing it without those heavy-duty immunosuppressants.
It could completely change how we think about type 1 diabetes, you know? Maybe it won't be this chronic condition you just manage. Maybe it'll be something you can actually solve.
That's a really hopeful thought.
It is. Of course, we need more research, more data, but the possibilities are really exciting.
Okay, so where does Sana go from here? The article mentions some next steps.
Yeah, they're going to keep a close eye on this first patient, see how things progress.
Making sure it's safe, right?
Absolutely, safety first.
Yeah.
And they want to see how long those transplanted cells last, how well they keep producing insulin.
Makes sense. They need that long-term data to really understand how well this works.
Exactly. And, you know, one thing to think about is the supply of those donor islet cells.
Right, because they're using cells from deceased donors, which obviously there's a limited supply of.
Yeah, that's a real consideration. It's a fantastic technology, but scaling it up, making it widely available, that could be a challenge.
But there's a lot of work being done on other ways to get those insulin-producing cells, right?
Oh yeah, there's a lot of research going on with stem cells, trying to create those beta cells in the lab.
So maybe down the line, we could combine this HIP technology with those lab-grown cells and really make it accessible to everyone.
That would be the ultimate goal, right? Make it available to anyone who needs it.
That's a pretty incredible vision. And, you know, this whole idea of cloaking cells from the immune system,
Yeah.
it has implications way beyond just type 1 diabetes.
Oh, absolutely. Think about organ transplants, gene therapies, all sorts of things.
If we could really figure out how to reliably bypass that immune rejection response.
The possibilities are huge. It would be a revolution in medicine.
So to wrap up our deep dive on this Beyond Type 1 article about Sana Biotechnology's HIP technology, the big takeaway is this early evidence, which is really promising, showing that a person with type 1 diabetes is now producing insulin after getting those specially engineered donor islet cells.
And the key here is they're doing it without needing any anti-rejection drugs.
Absolutely, that's the game changer. And we've got that C-peptide increase showing the body's actually making its own insulin again.
Right, and those MRI scans, that visual confirmation that the transplanted cells are alive and well.
All pointing to the success of this HIP technology in allowing those cells to do their job and stay under the radar of the immune system.
It's a very elegant solution, really.
Now, of course, we always have to say it, this is early stage research.
Of course, more research is always needed.
More studies, longer-term monitoring, all of that is essential to really prove that this is a safe and effective treatment.
Absolutely. But even at this early stage, you can see why there's so much excitement in the type 1 diabetes community.
Yeah, this could really change people's lives.
It really could. And it makes you think, you know, what if this is just the beginning? What if this idea of immune evasion, what if that unlocks treatments for all sorts of other diseases?
Other autoimmune diseases, transplant rejection, all those areas where the immune system is a major obstacle.
It's a whole new frontier in medicine, and it's incredibly exciting to think about where it could lead.
It really makes you wonder what the future holds. Well, on that note, I think we've covered a lot of ground today. Thanks for joining me for this deep dive.
My pleasure. Always happy to discuss these cutting-edge developments.
And for everyone listening, we'll be back soon with another deep dive into a fascinating topic that's shaping our world.
Looking forward to it.
Until then, stay curious.
Stay curious.